Good day, everyone. My name is Mohammed, and I'll be talking about the laws of thermodynamics. In physics, thermodynamics is the study of energy conversion between heat and mechanical work, and subsequently the macroscopic variables such as temperature, volume, and pressure. The starting point for most thermodynamic consideration are the laws of thermodynamics, which means that energy can be exchanged between physical systems as heat or work. In thermodynamics, interactions between large ensembles of objects are studied and categorized. A system is composed of particles whose average motions define its properties, which in turn are related to one another through equations of state. Properties can be combined to express internal energy and thermodynamic potentials, which are useful for determining conditions for equilibrium and spontaneous process. This typical thermodynamics engine shows that an input from a heat source boiler on the left and an output to a heat sink condenser on the right. Work is extracted, in this case, by a series of pistons. The zeroth law states that if two thermodynamic systems are in thermal equilibrium with a third, then they are in thermal equilibrium with each other. When two systems are put in contact with each other, there will be a net exchange of energy between them, unless or until they are in thermal equilibrium, that is the state of having a equal temperature. Although this concept of thermodynamics is fundamental, the need to state it explicitly was not widely perceived until the first third of the 20th century, long after the first three principles were already widely in use. Hence, it was numbered zero before the subsequent three. When two objects are separately in thermodynamic equilibrium with a third object, they are in equilibrium with each other. According to the first law, it states that energy cannot be created or destroyed. Rather, the amount of energy lost in a steady state process cannot be greater than the amount of energy gained. This is the statement of conservation of energy for a thermodynamic system. It refers to the two ways that a closed system transfers energy to and from its surroundings by the process of heating or cooling and the process of mechanical work. The rate of gain or loss in the stored energy of a system is determined by the rates of these two processes. In open systems, the flow of matter is another energy transfer mechanism, and extra terms must be included in the expression of the first law. Any thermodynamic system in an equilibrium state possesses a state variable called the internal energy. Between any two equilibrium states, the change in internal energy is equal to the difference of the heat transfer into the system and work done by the system. The second law states energy systems have a tendency to increase their entropy rather than decrease it. This can also be stated as heat can spontaneously flow from a higher temperature region to a lower temperature region, but not the other way around. Heat can appear to flow from cold to hot. For example, when a warm object is cooled in a refrigerator, but the transfer of energy is still from hot to cold. The heat from the object warms the surrounding air, which in turn heats and expands the refrigerant. The refrigerant is then compressed, expanding electrical energy. There is a useful thermodynamic variable called entropy, a natural process that starts in one equilibrium state and ends in another. Ends in another will go in the direction that causes the entropy of the system plus the environment to increase for a irreversible process and to remain constant for a reversible process. Thank you. That was all.